a client-server network architecture using point-to-point communication model and peer-to-peer network architecture based on publish-subscribe communication model differ in several aspects. And on those aspects we will take a look in this video. To better illustrate this, let's think about gRPC as a technology to create client-server network architecture, and let's think about DDS as a publish-subscribe technology used to create a peer-to-peer network architecture. In client-server network architecture, the roles of the server and individual clients are clearly defined. It's because the server is holding the data and clients accessing those data. But this leads to a system which is tightly coupled, and the communication occurs between server and individual clients, usually in a synchronous way, usually with request-reply pattern. And this centralized approach facilitates the data management and data control, but on the other hand, it can lead to potential bottleneck or single point of failure. On the other hand, with DDS, which uses publish-subscribe communication model and allows to create peer-to-peer network architecture, it's different, because in DDS you don't need to specify who is the server and who is the client, because each peer in such network can serve as a publisher and a subscriber at the same time. And in this decentralized approach, each peer has its own data. This enables more flexible and dynamic communication between peers without the need of the central server. And this decentralized approach has benefits in scalability, fault tolerance, loose coupling, and asynchronous communication. But there are some situations where you would utilize request-reply communication in your system. Is it possible with DDS? Yes, it is. It is possible to use request-reply communication on top of publish-subscribe communication. But for that, you need to create a request type and a reply type. Then you will need to create a request topic and a reply topic. Then you will need to utilize correlation IDs that will be used on both sides, so you can pair the request and reply. And you will also need to create a content filter, so you filter the responses with unwanted correlation IDs, so you get the right data. And unfortunately, it can get much more complicated because, for example, you will need to be prepared for multiple replies for a single request. And maybe there are more repliers on that request. So this can get much more complicated. But luckily, vendors like RTI or Proxima has ready-made solution for it, so you can use RPC over DDS. But this can be done from the DDS point of view in more easier or more natural way. How it can be done? It can be done with the pattern, design pattern, which is called objective state design pattern. How it works? When some application needs a change or wants a change in the system, this application sends a request to the system. And some application in the system will receive this request and make a change to the system state. The application changed something. And after that, this application will send an event as a reaction that the application changed the state. So the requester, the application that wants something to change in the system, receive the information that the change has occurred. And if something went wrong or goes wrong, the error event is created or sent. So in this case, for example, one application wants the state of the system or the state of the light bulb to be on. And someone in the system or some application in the system will receive this request, change the state of the light bulb to on, and send the event that the change has occurred and everything is okay. So this is the way how we can request any action in the system in DDS from the DDS perspective. All right, and there is one thing that the client-server network architecture is better suited than the peer-to-peer network that uses publish-subscribe communication like DDS. And that is the retrieval of the historical data. Because DDS is designed for real-time data, we call it data in motion, and it's not designed to retrieve historical data. So if you need in your system to retrieve historical data, it's better to take a look on other possible technologies that can you use for this. So overall, if you are comparing the client-server and peer-to-peer networks, you need to make a balance, or you need to specify your requirements on tight coupling, scalability, then your data distribution needs like request reply patterns and publish subscribe patterns. So, and also fault tolerance. So these are the aspects you will need to consider. And if you need to combine in your system request reply and publish subscribe communication pattern, I would recommend you to take a look at the Zenoch technology, which is designed from the beginning to use those patterns, and it's not an afterthought for this technology as it is for DDS. Alright, so if you found this video valuable and you are interested in DDS and related concepts, please subscribe to this channel. Bye.